Welcome. This is the first class of DC-AC electricity. And the first thing we want to do is get familiar with the terms that apply to electricity. And the first one is voltage. Voltage is the pressure that forces current to flow in a circuit. If you want the current to flow through a circuit, you have to have something pushing it. It's just like water pressure in your home. You want water to come out of the faucet with some pressure behind it. In small towns, they put up water towers that are way up above one of the highest things in the whole town. And gravity, because they have lots of water up in that water tower, will put pressure enough on that when you turn on the faucet, the water comes out. It's being pushed out by gravity, literally from that water tower. Now, in other places, like in big cities, they probably have pumps that will pump the water to create the pressure rather than just using gravity feed. But either way, you have to have some kind of pressure to get the water to go through the pipes. In electricity, you have to have some kind of pressure to get the electricity to flow through the wires. And that pressure is called voltage. Okay, the actual flow of current through the wires, that's called current. Current is the actual flow of electricity, and it's measured in amps. Likewise, voltage is measured in volts. So we have voltage measured in volts, current measured in amps. And finally, we have opposition to current flow. Opposition to current to flow is offered by resistors, as we'll see in the next few lessons. And in the real world out there, you might be using a light bulb as the resistance. And if you put enough current through the light bulb, have enough voltage, 120 volts, to force current through the light bulb, then, of course, the light bulb, the filament, heats up and gets very hot and glows, and that's what gives us light. Not nearly so much electricity is required for the LED lighting that's very popular today. Only about 1/10 or so of the electricity. So here are the three fundamental things of the three characteristics of electricity: voltage that pushes the current, current that actually flows, and resistance that opposes the current. Now, over here, I've got three rules that are considered together to be Ohm's law. Now, there are a lot of variations on Ohm's law, but you can add those to your skill set later as time progresses if you prefer to. However, these are what we need to get by. We can get by with these. We don't really need the others, but they're kind of handy. You can save a step or two sometimes. And we have one more that I haven't put up here yet, which is power. And power is equal to I times V, or power is equal to I times E. Thus, the saying power is as easy as pi, P-I-E. Okay, power is I times V. That's the one we're going to use most of the time here. Now, power is how much energy is being dissipated. In a motor, you have power being dissipated in the form of torque, most of it, and maybe a little bit on heat. But with resistors, the entire amount of power being dissipated or used up is in heat. So in later examples, we'll say which resistor gets hotter. That question is asking which resistor dissipates the most power. So I'm not going to say much more about power now, as you'll see that in a later lesson. But we're going to focus on the first three: voltage, current, and resistance. Voltage, current, and resistance. Now, you have three formulas here that in the beginning may be a little difficult to remember, but as time goes on, they'll become so familiar to you that you're not even going to think about it anymore. But at least for now, we need a shortcut that will teach us how to get uh, the value that we need for voltage, current, or resistance. Well, the shortcut is this little circle here. Now, if I put my hand over the one that I'm looking for example, here I'm looking for voltage. The formula for voltage is going to be I times R. Voltage equals I times R. That'd be if I put my hand over here, over the voltage, it would be I times R. Now, if I put my hand over the I end up with V over R, as indicated right here, V over R. And if I put my hand over the R, then I have V over I, which is indicated right here for resistance. These are together considered to be Ohm's law, and this is fundamental essentials to working with electricity. Next thing we're going to talk about is series. Now we're looking at a series circuit. What is series actually? Series is a situation where the resistors are connected end to end with nothing connected between. Now, this is a resistor right here, and there's another resistor and another one. And each of these are resistors. Resistors are, they oppose current flow, and they give it off the energy in the form of heat. We'll be talking about resistors a great deal in the coming 2 weeks. And now, in the first case here, we have a resistor here, here, and here. The question might be, are these in series? Well, are they end to end? Yeah, they are. Okay, they're end to end, so they must be, and there's nothing connected between them. Is there anything connected here? No. Is there anything connected here? No. Okay, so that is a series circuit. Now, if we look at the next one here, over here, we have a battery here on this at this spot right there, and then the current flows from the battery through the resistors. Are those resistors connected in series? They certainly are. That is a series circuit. Now, here's where it gets tricky. Resistor 1, resistor 2, and resistor 3 in this circuit, are they connected in series? The answer is no, they're not. And why not? Because we have something connected between R1 and R2. This green resistor right here is connected between. So that disqualifies it, right? Series is end-to-end with nothing connected between. And here I have a green resistor connected between. How about R2 and R3? Are they in series? No, they're not, because there's this green resistor connected between. Okay, so this is not series. However, the two green resistors here, is there anything connected out here between these resistors? No, we have nothing there. Consequently, these two, the two green ones, are in series, but R1, R2, and R3 are not, because they violate this rule, which says with nothing connected between, and I have green resistors connected between, so series rules do not apply there. Okay. Here we have a series circuit, and the circuit consists of a resistor of 1 ohm, 2 ohms, and 3 ohms. Ohms is the unit of measurement for resistance. And so now, just guessing, because this is our very first time we're going over this, we don't know much about this, but just guessing, how much total resistance would you think I have in this circuit? One resistor is 1 ohm, then 2 ohms, then 3 ohms. Well, if you guessed at 6, you'd be right. And 6 is the total resistance here, 6 ohms. And the reason for it is because what we do to get the total resistance is simply add up the 3 resistors in series. That makes it a little bit easier. So we know that for our total, all we have to do is just add. And that's how we got this. Now, we already are somewhat familiar with Ohm's law, which here, I'll put it up again. With Ohm's law, voltage is equal to the current times the resistance. Voltage equals current times the resistance. So we have that. Now I'm missing the current here, as you can see. So current is equal to voltage divided by resistance. And so if I want to find the current, I can use this equation. Current total is equal to voltage total divided by resistance total, which this would be equal to 30 volts divided by 6 ohms, which would equal 5 amps. Okay, so I know that the total here is 5 amps of current. Okay, that was using Ohm's law, voltage total over R total, because I is equal to V over R, and here's my totals. And I got the 5 amps out of this. Okay, I have 5 amps flowing through the battery. 5 amps flowing through the battery. That means that I have 5 amps leaving the battery, and I have 5 amps coming back into the battery because current flows through the battery. Okay, now what we want to do is to figure out how much current we have on these others. If I have 5 amps leaving the battery here, how much of it is going through this resistor up here? 5 amps, of course. And then if it goes from here, how much is going through this one? Again, 5 amps. Okay, and then I go through this one here. How much current is there at that point? 5 amps. And finally, I come back into the battery with the same 5 amps that left. So we know that each one of these is 5 amps. 5 amps here, 5 amps here, and 5 amps here. Okay. Now, would you say that we have the same 5 amps flowing all through here? That makes these all equal. We would say then that current is constant. All right, we're getting our rules put together here pretty well. Now, can I get the voltage for each of these? That should be pretty easy to accomplish. I'm going to take each one and multiply the current times the resistance, because voltage is equal to current times resistance. So 5 times 1 is how many volts? 5 volts. 5 times 2, 10 volts. 5 times 3, 15 volts. So now we know how to get the voltage using Ohm's law. And if I was to take the 5 volts up here and add to the 10 volts here and add to the 15 volts here, how much total voltage would I have in this circuit? That would come out to 30, wouldn't it? So in this case, to get the total voltage, we simply add the resistors. Okay, now the shortcut version of this, because we need a shortcut version, we have a lot of stuff to remember, so we have to get the shortcut version if we can. We always list voltage, current, and resistance, VIR, 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 VIR in this format, V first, then I, and then R. Okay, so now in series, which we have, the shortcut version of these rules right here is simply add constant, add. As you know, the smart people always get better grades and they study less. You may have noticed that through school. They don't study as hard as everybody else does. They don't have to put in as much time as everybody else does. Is that simply because they're smart? No, that's not it. They have strategies. And one of the strategies is to shortcut everything they can. And so instead of trying to memorize this, this is good for your notes. Put this in your notes. Voltage total is equal to VR1 plus VR2 plus VR3, add. Current total is equal to current through R1, R2, R3, constant. Resistance total, R1 plus R2 plus R3, and so on, add. That goes in your notes. But for study, this one right here works a whole lot better. Works a lot better. VIR, VIR, add constant add, VIR, add constant add, VIR, add constant add. And that's pretty much what you want to say in this situation, that you just add these together. For voltage, current is constant, and resistance, just add them together. And it better come out that way. If you end up getting a sum of the voltages around here, which is not equal to this value here, then you've obviously made a mistake. If the sum of these voltages around here doesn't equal this voltage here, then you made a mistake. Now, the only thing that's different, not adding at all, is the current. The current is constant. So the same current that we have total, that same 5 amps goes through here, 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 and returns back here. Okay. So that is pretty much it for the series circuits and that sort of thing. Now we're going to get into a little bit more complex of a series circuit, and I'll do that next. Here we have a series circuit, and our total resistance is 10 ohms. And I have 2 ohms here, 4 ohms here, and 1 ohm here. And instead of having a resistance value given here, I've got a voltage. And we're supposed to go through and figure out all the voltages, all the currents, and any resistance that might be missing. In this case, it's only one resistance. Well, in order to use Ohm's law, we know that we have to have 2 variables. If I want to find the voltage, I have to have current and resistance. If I want to find the resistance, I have to have voltage and current, and so on, as we've already covered. Now, our total resistance here is 10 ohms. How much of that resistance is accounted for? Let's find out. We have 2 ohms here, 4 ohms here, and 1 ohm here. So this is 2 plus 4 is 6, and 1 is 7. 7 ohms is accounted for. How much is missing in this case? It would have to be 3 ohms. Okay. Does that mean out of necessity R3 must be 3 ohms? Exactly, that's what that means. Okay, now if I put 3 ohms in on position 3 here, on resistor 3, 3 ohms. Okay, does the sum of the resistors in the loop, 2 ohms, 4 ohms, 3 ohms, and 1 ohm, does that totally equal 10 ohms? It should equal that. Now, since I have 2 variables here on the 3rd position, can I easily calculate the current and get that? Yeah, I can. I've got 12 volts and 3 ohms. And we know that current is equal to voltage divided by resistance. Consequently, at this point, we're going to have 4 amps of current. Okay, what do we know about current in a series circuit? Well, the rules say that in a series circuit, current is constant. Does that necessarily mean that all 4 resistors get the same current? Yes, it does. So I'm going to put at each position here 4 amps, 4 amps here, and 4 amps up here, and of course 4 amps total. Now, since I have 2 variables at every location, can I ultimately find the third one? That should be pretty straightforward and easy. We know that voltage is equal to current times resistance. And so the voltage here is going to be 4 volts. The voltage here we already know is 12. The voltage here is going to be 16 volts. And the voltage here will be 8 volts. Now, 8 and 16 is 24. And 12 is 36. And 4 is 40. So I could use our series rules to add up the voltages around the loop and get 40 volts here. Or I can simply say that voltage is equal to current times resistance, 4 amps times 10 ohms. Here we have a circuit that's just a little bit more difficult than the ones we've been doing, or the one that we did. In this case, I've got 3 voltages given. I got the R total. I've got the voltage here on R2. I got the voltage here on R3. But I got resistance on R4 and R1. Now, when you combine resistors together, we're going to see which one we have the most of. We have the most of resistances here. No, voltages. The voltages are the most. We have 3 voltages. A voltage here, a voltage here, and a voltage here. So I'm going to take the ones that I have the least of, these two, and combine them. So what I'm going to do is take this resistance right here and this resistance right here. And these two are going to be combined into a VIR box that I put here. Voltage, current, and resistance. And the only purpose for using this VIR box is to get the current. If I can get the current, because I've got one variable at every location, I can easily solve this problem. But it's important for me to get the current. And that's what I'm going to try to do here now. Okay, you have to pay pretty close attention to this. Probably not a good idea to take notes at the moment, but just to listen up and then take notes on the second pass. Watch the video again a second time. Here I have 1 ohm and 9 ohms for a total of 10 ohms. Okay, now I have 80 volts and I have 40 accounted for. How much does that leave me? That leaves me with 40 volts. Now that 40 volts must go on these 2 resistors, which I've combined over here. So I'm going to put here that 40 volts, the one that's missing right here, this one. Okay, now I can easily determine the current. 40 divided by 10 is 4 amps. Okay, now the 4 amps goes where exactly? Everywhere. Now here's the thing. I don't know how much voltage goes here, and I don't know how much goes here, but I know that the total of these two is 40, correct? Because that's the missing value. So 40 volts that I have right here is accounted for out of the 80, but the 40 volts that's missing goes here and here, as I've indicated at this point. Now, the thing I have to do next, because I don't know, is it 20 and 20, 30 and 10, 5 and 35? I have no idea how that breaks down. So I'm going to combine these to get the current. Now, once I have the current, where does the current go? It goes everywhere. So the current here goes 4 amps, 4 amps, 4 amps, 4 amps, and over here, 4 amps. Okay, here I know that 80 divided by 4 is 20 ohms. And here, 24 divided by 4 is 6 ohms. And 16 divided by 4 is 4 ohms. And I've got two voltages that I have to get now, which is down here, 36 volts, 4 amps times 9 ohms, 36 volts. And up here, 4 volts. Now, we know they're supposed to add up to 80. 36 and 4 is 40. 16 and 24 is 40. So 40 and 40 equals 80. That works out. The current is constant. That works out. And 20. 1 plus 4 is 5, plus 6 is 11, plus 9 is 20. Okay, all worked out here. I needed this to get the current, and once the current came through, I knew how to divide up the 40 volts, which was supposed to go on these two resistors. It turned out to be 4 and 36. It could have been 30 and 10 or any other combination. But once I got the current, then I knew exactly how much voltage went up here and how much voltage went down here. Now you might want to review this video and take notes on it a little bit, and that'd be very helpful.